Hey, this is Unit 2, Day 1b, and this is all about quadratics. So this is hopefully a review from Algebra 2. Some of our learning targets here, I want to be able to graph quadratic equations in standard form. I want to be able to graph them in vertex form, and then I can also solve quadratic applications. So today's going to be a lot of I guess in-between work, so I'm going to be pausing the video, writing a few lines of work down just to save some time. If you need to pause it and refresh yourself, make sure you know how to do some of the transformation from one form to the other. Do that, okay, and pause it, rewind it, and see if you can do it. But this first one, so we're going to look at it three different ways. You got vertex form, standard form, and then graphing it. If it's in vertex form, it's awesome because it tells you the vertex. The vertex is HK. Okay, so whatever you're subtracting is the H, and whatever you're adding is the K. So that's the Y coordinate of the vertex, and this is the X coordinate of the vertex. So here, when it says X plus 2, you say, what am I subtracting? Well, that's the same thing as minus negative 2. So on this one, my vertex would be negative 2, and then over here, negative 3. And then the axis of symmetry, let's put AOS, axis of symmetry would be x equals this value. Remember, the vertex is the highest point or lowest point, so it always goes through the axis of symmetry for a quadratic, for a parabola. Okay, so from here, I could graph it. So, or at least I could graph some of it. So negative 2, negative 3, and then there's this axis of symmetry running through here. Okay. Now, if we were simply going to graph from this, we'd pick maybe one or probably two more test points. And since I know what y is when x is negative 1, I'd pick numbers, negative 2. I would pick numbers close to negative 2, like negative 1 and 0, and see what I get. Plug them in and see what you get. Now, if I look at it in standard form, this tells you some stuff also. This is awesome. I like vertex form a whole lot better, but standard form does have some value to it. So first off, if it's given to you in in standard form, if it's given to you in this form, you're not going to be able to tell the h and the k right off the bat, but you could find it pretty quickly by going negative b over 2a. So the opposite of this over 2 times that would give you the x coordinate of the vertex, which is actually ends up being the axis of symmetry also. Negative b over 2a is the axis of symmetry. And then f of x says plug that x in. So whatever you get here, say you get 2, plug 2 in and see what comes out, and that's the y coordinate. Okay, so for this one, I need to convert from vertex form to standard form. So to do that, I almost think of it as simplify it, multiply it out. Okay, so I'm going to square this and then subtract 3. So if I had x plus 2 squared, that'd be x squared plus 4x plus 4, and then minus 3 on the end. So y equals x squared plus 4x plus 1. That 1, that c right there, is a y-intercept. Okay, so that's like the one thing that right off the bat you can see when it's in standard form, my y-intercept. So this one's going to have a y-intercept of 1. It's going to cross y-axis at 1. Because the axis of symmetry is here, it's 2 units to the right of the axis of symmetry, go 2 units to the left of the axis of symmetry. And that's enough to plot it. I'd still say, do one more point. Plug in negative 1 or negative 3. Either way, you get the same answer. And in this case, just saving some time, if I plug it in, I'd get negative 2, mirror that guy over. So there's my parabola. Okay, now let's say, cover this up, let's say this is what was given to me. Again, if I needed to find that vertex, take negative b, so it would be negative 4 over 2 times a, which is 1. And I would get negative 2. Happens to match. And then I need to figure out what is f of negative 2. So if I plug negative 2 in here, negative 2 squared is 4, plus, and then negative 2 times 4 is negative 8, so 4 plus negative 8 would be negative 4, plus 1 would be negative 3. Happens to match. But if I didn't know that, I'd have to do it this way. Okay? Okay, a little bit faster here. Let's say I'm given this. I don't have the vertex form, so I can't tell the vertex just by looking at it, but I can find the y-intercept right off the bat is plus 2. And why is that? I guess I said it, but I didn't say why it was. If any point is on the y-axis, its x value is 0, so it's 0 comma something. Plug in 0, those terms are gone, and this number on the end is the only one that's not affected by that. So the number on the end is the y-intercept. Now, if I want to find the vertex, again, it's going to be negative b, so it's going to be opposite of negative 6, all over 2 times 3. And then it's going to be f of whatever this is, so I'll just say 6 over 2 times 3. Now, that happens to be 1, so it's going to be 1, comma, now plug 1 in, so 1 squared is 1, that'd be 3 minus 6 plus 2, would that be negative 1? So the vertex is at 1, negative 1. The axis of symmetry has the x coordinate of the vertex is the axis of symmetry. Mirror that guy over. And again, there's your U shape. Try to make it a U shape, not a V shape. So there's your U shape. Okay. Whoops, I went up 2, didn't I? Wait a second. Oh, that's right. Yeah. Okay. Just messing myself up here because it is 2. That's negative 1. All right, now going backwards. This one's a little tricky. I want to go backwards, and this is basically we're going to be doing a version of complete the square. Okay, so what I want to have in vertex form, I need to have a binomial squared. I need that to be a 1. So the first thing I'm going to do is I'm going to divide a 3. I'm going to divide a 3 out of these two. Actually, I'm going to separate it. So I'm going to take, let's see, 3x squared minus 6. I'm going to put plus 2 on the end. I'm kind of pushing it away. I'm going to take a 3 out of both of these. So 3x squared minus 2x plus 2. So this one, just this plus 2, I didn't do anything with, hanging out over here. Now I want to know what number do I put in here to make this a binomial squared. So x plus or minus something squared. So that thing, it's always going to be half of this number squared. And half of this number is actually what goes here. So half of negative 2 is negative 1. Negative 1 squared is 1. Notice x minus 1 squared is x squared minus 2x plus 1. Thing was, I just added something. I put a plus 1 in here on this side of the equation. So technically that does not equal y anymore because I added something to the right side of the equation. I also didn't just add 1 because whatever I put inside parentheses is actually being tripled. Okay, so this is actually, I added 3 to the right side of the equation. So right now the right side is 3 too heavy, okay? So it's a little too heavy, so I got to undo that. I'm going to subtract 3 on the end. That way, this addition of plus 1 times 3 and then a minus 3 is even again. The right side of the equation, so we're back to being equal to y again. So this be a minus 1 on it because 2 minus 3 is negative 1. And again, that's called complete the square. That whole idea is called completing the square. So if you need a little review on that, that's what it's called. You can look it up, or you can always talk to me in class and I can go through a few more examples. So there's vertex form. We said the vertex was 1, negative 1. What am I subtracting here? 1 minus 1. So there's my vertex. Got the same answer. Okay, so a little bit quicker now. Again, same thing here. Going back to vertex form, I'm going to put the 4x squared minus 2x. I'm going to push the 6 off to the right. I'm going to divide. I want this always be a 1. I want x squared to be a 1. So I'm going to take a 4 out of both of those. I don't want that there. Let me pause. Okay, I want this parenthesis more over here. And now I'm going to add something inside of there so that it is some binomial squared. And the trick is always half of this, so that'd be negative 1/4. Negative 1/4 squared is plus 1/16. Okay. Again, I just added something to this right side. I added 1/16 here. So this right side is 1/16 times 4 bigger than it was before. So that's actually 1/4 because 1/16 times 4 is 4/16. So I just added 4/16 or 1/4 to this side. That means I need to subtract 1/4 to balance it out so that it still equals y. So this would be plus 5 3/4. So the vertex is going to be at 1/4, 5 3/4. So over here, go 1/4 over, and then 5 3/4 is somewhere up here. And it's going to be 6 is the y-intercept. So it's gonna, oops. It's up there somewhere. If we're just giving a quick sketch, it's up in that area. Okay? And then this guy here, we just got a graph. So looking at this graph right here, this vertex is at -3, -2. And the, let's see here, what else can we do? So if we want to write this in vertex form, the things that I know about it, I know the H and the K. I just don't know if that A is necessarily 1. Sometimes students make the assumption that it's 1, and a lot of times it is 1. But like here, it's a 3, here it's a 4, and that does have to do with the vertical stretch on it. If you remember, you have a number out front, it's going to be a vertical stretch. So what I'm going to do is I'm going to leave that as A. So I got x minus -3 squared plus -2. So just I'll put plus -2 and I'll fix that later. So this is going to be plus here. So I got y equals a x plus 3 squared minus 2. And then to solve for a, plug in a point that you know. Okay, so plug in some point that you know on the graph. Now, if you do -3, -2, you won't be able to find anything, because when I plug in -3 in here, that'd be 0. 0 squared is 0 times a is going to get rid of a. A disappears before we find it. So you just can't use that vertex. We got to find a point besides the vertex. And it sure looks like here, this would be -1, 0. So I'm going to plug in -1 for x and 0 for y. So 0 equals a, -1 plus 3 squared minus 2. This would be 4. So a times 4 minus 2. If I add the 2 to their side and divide by 4, a equals, I'm getting off the screen. Okay, so I divide both sides by 4 to solve for a, I get 1/2. So y equals 1/2 x plus 3 squared minus 2. That's the vertex form. Okay, so you got to find that a. Don't just assume it's a 1. You know, it'd be nice if it always was a 1, but it's not. So now, if we're going to FOIL this guy out, this would be 1/2 x squared plus 6x plus 9 minus 2. So 1/2 x squared plus 3x. I'm just going to say 9/2 minus 2. And I got 9/2, which is, what, 4.5 minus 2 would be 2.5, so plus 2 1/2. So there's a standard form. Okay, now, we said our other learning target was solving quadratic applications. So here comes that idea. So first off, just a quick summary of quadratics. It's a polynomial of degree 2. Here's standard form, here's vertex form, all that good stuff. Don't forget, you can use quadratic formula to find the x-intercepts. So if you're desperate for more points, you could plug it in the quadratic formula. If you get a negative under the radical, that means you have imaginary solutions, which it's just a graph that doesn't cross the x-axis. Maybe it's something like that. That would have imaginary x-intercepts. So that's kind of stinks when that happens. But so applications here. So a Dud missile is fired straight into the air from a military installation. The missile's height is given by this formula. Okay, so it must not have any propulsion on it. It just goes up and gravity pulls it back down. So how high is a missile after 4.5 seconds? So what I'll just do, you can do this on your calculator, plug 4.5 in for the t's and evaluate. So that one's not too hard, 1576. And that's height. It doesn't say what the height is, if it's in meters or feet or what it is. We'll just say units. Part B, what time will the missile reach its maximum height? So what I'm really asking you is what's the vertex, and specifically when it says time is the x-coordinate. So I'm looking for the x-coordinate of the vertex. Well, if this is in standard form, -b over 2a will get the trick done. Or get the job done and do the trick. So I got negative b, so negative 400 over 2 times negative 16. Again, you put it in a calculator, that's 12.5 seconds. So at 12.5 seconds, it'll reach its maximum height. And then what is the maximum height? Height is y value. So what I'm trying to find the y value now, that means plug it in. So take h of 12.5. Again, I'll let you put that in the calculator. It's 2,600. When will the missile be 2,500 feet above the ground? So what I'm saying is, so 2,500 is my h of t, and I'm trying to find what t gives me that. Okay, so this guy, to solve it, I need this to equal 0, so I'm going to bring that over. So 0 equals negative 16t squared plus 400t minus 2,400. And you could graph it and look for the x-intercepts, just because I think it's nice to not forget this. You could factor this guy. So if all of these they're all divisible by the same thing, first off. So they're all divisible by negative 16. So that gives me a t squared minus 25t plus 150. And positive product, negative sum, so they're both negative. And then what times what equals 150, but adds you negative 25, so negative 10 and negative 15. So if this equals 0, that means t equals 10 and 15. So you could factor it. Now, if you started factoring and you got stuck or it just didn't factor nicely, that works. You could do the quadratic formula, or you could put it in the calculator and look for the x-intercepts. When will the missile be 100 feet off the ground? So I'm going to set this equal to 100. And when I bring the 100 over, this would be 0 equals negative 16t squared plus 400t plus 0. And now that one's a little bit easier to factor. I could take a negative 16t out of both of those. So this would be negative 16t times, let's see, t minus 25, yeah. So if this equals 0, that means t equals 0 or 25. So when it's shot, the moment before it leaves, it's 100 feet off the ground, and then 25 seconds later, it's 100 feet off the ground. So if it makes sense that in between there would be when it peaked. So if at 0, it's 100 feet off the ground, and at 25, it's 100, well, halfway between. Some cool things about this. We didn't really know this, but this is on Earth. This has to do with gravity, because all things on Earth follow this pattern. Okay, so the height s and vertical velocity v, and that just means when it comes out, this is or I should say the vertical velocity is any velocity any time, but it's just up and down. So this, if we shoot something at an angle out of a cannon, say a 45-degree angle, this one, it doesn't follow this pattern. But if you shoot it straight up in the air and it comes straight down, it's going to follow this formula. Okay, so t is seconds. Gravity, depending on if you're talking about feet per second squared or meters per second squared. If it's feet, it's 32. If it's meters, it's 9.8. And that's the acceleration due to gravity. And then v sub 0 is the initial. So when it comes out, that's the initial velocity. And s sub 0 is this initial height. So where it started, the initial height. So a juggler, so we're going to, instead of them giving us the function up here like they did up here, instead of them giving us the function, we're going to write the function ourselves. So a juggler tosses a ball into the air. The ball leaves 5 feet above the ground. So that's your s sub 0, has initial velocity of 31 feet per second. That's my v sub 0. And notice it said feet per second, so I'm going to be using 32 feet per second squared for gravity, because we're talking about feet here and not meters. So write an equation that represents the height. So the height with respect to time would be, in this case, it'd be negative 1/2 times 32. And kind of a shortcut, it's always just do negative 16 if we're talking about feet. Negative 16. t squared plus the initial velocity was 31 feet per second plus the initial height, which this is going to reduce or simplify to negative 16. So negative 16 t squared is 31t plus 5. How long will it take the ball to reach its maximum height? So that just means at what time will it get to the vertex? X coordinate of the vertex, because time, how long will it take? Time is the x coordinate. So that's a negative b over 2a. So negative 31 over 2 times negative 16, so it'd be 31 over 32 seconds. I'm not even going to divide that, I just leave like that. So that's how long it would take to get the maximum height. I didn't put it here, but what is the maximum height? I'll say max height. Well, plug 30 seconds into this function. It was 20.02 feet. That's the highest it ever goes. So this juggler is throwing it pretty high in the air. About 5 feet. His hand's about 5 feet off the ground. He's throwing it 20 feet in the air. That's a pretty good toss for... letter C. If the juggler catches a ball when it falls back to a height of 3 feet, how long will the ball be in the air? So it goes up and it comes back down to 3 feet. So we want to know, when does the height equal 3? So this would be negative 16t squared plus 31t plus 5. I think you could do Pythagorean, you could do the quadratic formula. I almost said Pythagorean theorem. You could do the quadratic formula and find it, or you can put it in a calculator and find it. It does end up being, the two answers are 2 and negative 0.0625. So obviously we didn't go back in time. What that's saying is it leaves their hand at 5 feet, goes up to 20 feet, and then comes back down to 3 feet. And it took 2 seconds to do that. The negative 0.06 was if we went back in time to 3 feet this way, but we can't go back in time, so that one's out. An auditorium has seats for 1,200 people. For the past several days, the auditorium has been filled to capacity for each show. Tickets currently cost $5, and the owner wants to increase the ticket prices. He estimates that for each 50-cent increase in price, 100 fewer people will attend. What price will maximize the profit? So profit is going to equal the number of tickets times the price per ticket. And what's changing here, the thing that's going to change is, X represent the 50-cent increases. So 50-cent increases. So the number of tickets, right now it's 1,200, but for every 50-cent increase, for every one of those, we're going to lose 100 people. Okay, so that's 1. That's the number of tickets. Now let's do price. So right now it costs $5, the price per ticket, but we're going to add about 50 cents for every 50-cent increase. That kind of makes sense. Okay, and that's going to equal my price with respect to the number of increases. So if you plot this on your calculator, so put in the y equals here, and I'm trying to find, I want to maximize profit. So in this case, keep in mind the y-axis is profit, the x-axis profit. The x-axis going this way is number of 50-cent increases. Okay, so whenever I hit graph on this guy, definitely not anywhere near what I want to see. So I'm going to go to zoom, and then I'm going to see if zoom fit works. So here, let me turn that so you can see it so there's no glare. Okay, so somewhere in here now, this is not usable domain over here because this says negative. That means we increase the price, right? Or, I'm sorry, that means we decrease the price. We're not going that route. He wants to increase the price, and plus the maximum is right. That's on the positive side. So second calc, maximum. Put some numbers in here. So it looks like if I do one 50-cent increase, so when x equals 1, the profit equals $6,050. So he needs to do one 50-cent increase to maximize profit. But what's that ticket price? Well, it's not one. It would be one increase of 50 cents, so $5.50. So be careful what you're actually answering here. Sometimes X is not your final answer.